How your body uses protein. The body relies on 3 macronutrients: protein, carbohydrates and fat, as well as many micronutrients. Unlike carbohydrates and fats, protein is not easily stored in the body. However, it will store protein just like the nutrients if there are too many calories consumed. Fat is the easiest to digest for the body. The body digests carbs based on what kind they are. Simple carbs are fast and easy to digest and lead to sugar spikes that can cause weight gain. Complex carbs, on the other hand, take longer for the body to digest and do not contribute to the sugar spike, insulin surge cycle. Proteins are the hardest for the body to digest and start burning energy from the moment that they enter the bloodstream. Proteins, in addition to being slow to digest, are vital for every cell in the body and play a major role in a number of functions. Despite the importance of the nutrient, there is an upper limit to the amount of protein that is needed by the body. Ironically, the need for protein is never greater than in the first 6 months of human life, when pound for pound, the protein need is double what it will be for the rest of life, no matter what the circumstance or life stage. Some of the roles of protein. The most obvious role of protein is in the creation and repair of muscles, but there are countless others. These include building of connective tissue, building cell membranes, contributing to the bone matrix, regulating the pH balance of the blood, forming hormones and enzymes, including those that play a role in the regulation of sleep, digestion and ovulation, boosting immune function. Antibodies are proteins, creating new blood cells, creating RNA and DNA, creating neurotransmitters. Source: Nelson, 2009. The digestive process of protein. All proteins are made of a number of amino acids. While the human body can create many of these amino acids on its own, there are 8 which are not made in the human body and must come from food sources every day. These are called the essential amino acids. A protein is either considered to be complete, meaning that it has all 8 of the essential amino acids, or incomplete, meaning that it is lacking 1 or more of them. These 8 amino acids are leucine, isoleucine, valine, threonine, methionine, phenylalanine, tryptophan and lysine. Animal proteins are complete, while most plant proteins are not. These amino acids are technically simple compounds created from molecules of carbon, hydrogen, oxygen or nitrogen. Each of the amino acids will link together to form a chain, which are then referred to as a peptide. The average peptide will have over 500 amino acids in it. Each protein is broken down into the simple amino acids during the digestive process. These in turn are absorbed and used by the body to make new amino acids, enzymes and hormones. During digestion, the protein is first sent to the stomach, by hydrochloric acid in the stomach's gastric acid breaks it down into its first components. The gastric enzyme pepsin, which is the only protease able to digest collagen, a protein in animal connective tissue, digests the amino acids. Enzymes are classified as either proteinases or proteases. The next step in the process takes place in the duodenum, the first segment of the small intestine. Here, the pancreas will deliver its own protease enzymes, trypsin and thymocypsin. Trypsin works to break down the protein into amino acids through a process called hydrolysis, where a water molecule is inserted between 2 amino acids to break their bond and separate them. At this point in the digestive process, the amino acids are small enough to pass through the intestinal lining and throughout the rest of the body. During exercise, the production of the body's proteins is decreased. The remaining protein is then converted to free amino acids and used for fuel for the working muscle groups. After the exercise is done, especially in the case of heavy resistance training, the rate of protein synthesis remains low while breakdown rates remains elevated for about 24 hours. Without a new source of protein during this, the recovery period, the breakdown will likely exceed that of synthesis and the body will turn to its own muscles for fuel. Evaluating proteins. All proteins, especially those being used by elite, endurance and strength athletes, are evaluated on 2 scales. The Protein Digestibility Corrected Amino Acid Score, PDCAA, judges the completeness of a protein. A complete protein, meaning one that has all 8 essential amino acids, will earn a score of 1 on this scale. The second score is the biological value, BV, score, which will judge how much of a protein is actually retained by the body after it is broken down. All protein types are often judged against the egg on this scale because it scores 100, meaning that all of the protein that you get from eating an egg is retained by the body. Unless you are an elite athlete, it is not likely that you know or care about the PDCAA or BV score of your protein, and there are simpler ways to evaluate the foods and supplements that you consume. Your proteins should be low fat, especially in saturated fat. They should be low in calories, or at least not extremely high in calories in relation to the portion size. Finally, they should taste good and have other nutritional benefits as well. Protein supplements should be high in protein but low in calories and should not have added sugars or fats. Read all labels carefully, since some of the brands of protein bars are trying to pretend to be healthy when they bear little difference from the average candy bar. Know your protein need. From the infant in his cradle to the elite bodybuilder to the old man who is playing shuffleboard, all humans need protein. Their actual need is as individual as they are, based on their age, their health, their weight and their activity level. Protein is important, but it can also be dangerous when consumed in extremely high amounts. The experts suggest that the upper limit is no more than 35% of the total daily calories, even for the elite athletes. As mentioned before, there is no greater need for protein than during the first 6 months of life, when the baby should be getting 2.2 grams of protein per kg of body weight. The elite bodybuilder, on the other hand, should be getting around 1.6 grams per kg of body weight. Source: U.S. Guidelines on Protein and Nutrition. For the average-sized man, that translates to roughly about 60 grams of protein per day, or about 8 ounces of meat. Women need less protein than men, unless they are pregnant, when the need increases dramatically. However, when a woman is not pregnant, excessive protein can lead to increased calcium loss through the urine, putting her at a greater risk for developing osteoporosis. Source: Sang, RD 2007. For the average person, the protein need is between 0.5 and 0.8 grams per kg of body weight each day, more if you are very active and less if you sedentary. Timing is important as well, with athletes advised to eat a small protein meal or take their choice of protein supplement before they work out and immediately afterwards so that the body does not resort to tearing down its own muscle mass in search of energy.